When we're comparing multiple means, we can think about our research question in either of two different ways. One way is to think of having a quantitative variable measured across 3 or more groups, and we want to know whether there's a difference among any of the means. The other way to think of it is to think of testing for an association between a quantitative response variable and a categorical explanatory variable with 3 or more categories. If you've ever wished that your textbooks came with more pictures, you might be interested in the research question, do pictures improve reading comprehension? In this study, 57 students read a confusing paragraph, and they were divided randomly into groups. One group saw no picture, they just read the paragraph. One group saw the picture before they read the paragraph, and the third group saw the picture after they read the paragraph. And if you want to read this confusing paragraph and see the picture that explains it, you can check out section 9.1 in our textbook. Then, all of the students took a test about what they read. In this study, our null hypothesis is that the mean reading comprehension score, mu, in the population is the same among all 3 groups. And our alternative hypothesis is that at least one of the means is different from the others. So, like the chi-squared test of independence, the alternative hypothesis is not that all 3 of the groups are different from each other, just that at least one, maybe all 3 are different. Another way we could write our null hypothesis would be to say that in the population there is no association between reading comprehension and whether or when the picture was shown. In this case, our alternative hypothesis would be that there is an association between reading comprehension and whether or when the picture is shown. To compute a simulation-based p-value for this study, we need to be able to simulate from the null hypothesis. In other words, we need to be able to simulate a situation where people's reading comprehension scores really have nothing to do with which group they're in. We can do this by imagining that we have index cards, and we've written people's reading comprehension scores on the cards. We shuffle up the cards and deal them randomly into 3 groups: a simulated no picture group, a simulated before picture group, and a simulated after picture group. So because we shuffled the cards, there's no relationship between the numbers written on the cards and which pile they ended up in. Then we'll compute the statistic for the shuffled data, and for this type of test, the statistic we'll use is called the MAD statistic. We'll talk about that more in a moment. And repeat this a lot of times, say 1,000. The statistic we'll use for a test of multiple means is called the mean absolute difference, or MAD statistic. The idea here is that we'll find the difference of sample means, x bar 1 minus x bar 2, for every pair of groups, 1 and 2, and take the absolute value of that, so it becomes positive, regardless of which order we did the subtraction in. And then we'll take the mean of those differences across all the pairs of groups. So if the groups are very similar in their means, we will get a MAD statistic close to 0. And if they're very different in their means, we'll get a MAD statistic that's a large positive number. So here I have the data for the reading comprehension study. It's the data set called Comprehension on our textbook website. I'll press Ctrl-A to highlight all and Ctrl-C to copy. And then I'll switch over to the multiple means applet. This is the same applet that we used to test for a difference in means between 2 groups. I'll clear out the default data in the applet and then press Ctrl-V to paste in the data for this study, and then click Use Data.
So here we can see the data from our given sample. And we have in green on top the reading comprehension scores for people who saw no picture. In red in the middle, people who saw the picture before they read the paragraph. And in black on the bottom, people who saw the picture after they read the paragraph. And it does look like there might be an association here between reading comprehension score and which group people belong to. It looks like there might be a tendency toward people having higher reading comprehension scores if they saw the picture before they read the paragraph. So let's see if that's statistically significant. I'm going to scroll down and choose the statistic to be the MAD statistic. My observed MAD statistic is 1.158. Then we'll show the shuffle options. And we can start by doing a single shuffle. And what we can see here in the shuffled data is it has the same values for after, before, and none, and the same values for reading comprehension as in the original data. So all that we've done is shuffled up which row each data point belongs to. So there's no longer a connection between which column someone is, or which row someone is in for the first column, which group they were in, and what their value is for the reading comprehension score in the second column. Another way we can visualize this is with the plot, where we can see that we've now mixed up the red, black, and green dots, and it looks like all three of the groups have a more similar mean, consistent with the null hypothesis being that there's no difference between the means of the three groups. So this particular sample had a MAD statistic of 0.421, which we can see in the upper left-hand corner of our null distribution, and that's graphed in the blue dot shown here. So let's do this 999 more times. So here we see our null distribution of the MAD statistic. And you can see that it has a lower bound at 0, and it's a little bit right skewed. So in order to find the p-value, we want to count samples that are at least as extreme as what we observed in the actual data, which was 1.158. And for the MAD statistic, like the chi-squared statistic, because larger values always indicate stronger evidence against the null hypothesis, we're always going to want to count samples that are greater than or equal to our MAD statistic. So that gives us 2 out of 1,000 simulations that were at least as extreme as 1.158. So our p-value is 0.002.
So our conclusion is there is very strong evidence that at least one long-run mean reading comprehension score is different from the others. From this test, we can't tell which mean or means are different, although we might have a pretty good guess based on the box plot and dot plot of the data. Take a moment to think about how we could figure out which means are different. The answer is by doing a series of 2-sample t-tests for different pairs of the data. So a test of multiple means can save us a lot of time if we turn out to get a large p-value that says that it's plausible that all of the means could be equal to each other. In this case, that would prevent us from having to do 3 different 2-sample t-tests, one for each pair of the 3 groups. Another way we could phrase our conclusion would be to say that there is very strong evidence that reading comprehension score is associated with whether or when a person sees the picture.